You know, airplanes are mysterious things. Unimaginably heavy metal giants soaring through the sky, jam-packed with not only people but also all kinds of electronic gizmos and overhead bins stuffed with their oversized luggage. And perhaps children. No, not really. What confuses me the most, however, is the airplane's tires. Yeah, really. I mean, look at them compared to the plane's body. They're tiny. How can they withstand all that weight and speed? Okay, let's check out what's happening when a plane is preparing to land on the runway. While still in the air, its speed is becoming lower and lower, and that's when you might feel your ears getting congested. You also sense that the plane has seemingly started crawling at a snail's pace, when just a second ago it was moving at breakneck speed. In their flight deck, the pilots are slowing the plane down even more and getting ready to lower the landing gear, which is often called the undercarriage. That's a complex mechanism that consists of structural components, energy absorbers, brakes, hydraulics, and of course the wheels and tires. From your seat, you can hear a distinct robotic noise. That's the landing gear and wing flaps being lowered. Then, when the airplane is about to land, its nose starts pointing upward. Now, if that seems counterintuitive, think about water skis. When a skier is moving across the water surface, their skis are always inclined upward. Otherwise, both the skier and the skis would go under the water. The same approach goes for airplanes. Pilots must point the aircraft nose toward the sky just before landing so that they don't stall the machine. Plus, exposing all that large surface area on the wings and belly will help slow the speed of descent. Anyway, several seconds later, all 300 tons of your airplane touch the ground while still going 170 miles per hour. Imagine your typical two-story house, fully furnished, dropping to the ground as fast as a flying arrow. That must be quite an impact. And still, those tiny, comparatively little tires don't pop under the tremendous pressure. This incredible feat has to do with the materials airplane tires are made of, the gas that fills these tires, and the way they're inflated. To make an airplane tire, producers use a mix of different kinds of synthetic rubber. It makes aircraft tires so strong that each of them can easily deal with a 38-ton load. Didn't you just say 300 total tonnage? Hey, good memory, yes I did. But remember, there can be anywhere from 14 to 22 tires on one jumbo jet. They're durable too. A plane can touch the ground up to 500 times before its tires will need to be covered with a new layer of rubber. But what makes tires so tough is mostly nylon cores under the tread and special aluminum steel reinforcements. Then there's the gas they have inside. It's not oxygen. At very low temperatures, oxygen can turn into ice right inside the tires. Of course, the temperature must be extreme for this to happen, about minus 360 degrees Fahrenheit. But you never know with air travel. As for high temperatures, like during braking, they can trigger a reaction between oxygen and rubber. When those two mix, the rubber becomes weaker. And nobody wants weak airplane tires. They can explode. So that's why the gas that fills aircraft tires is nitrogen. It doesn't react with rubber, which makes it a much safer choice for airplanes. It also doesn't leak through the rubber as fast as oxygen does. Meaning tires that are filled with 95% oxygen remain inflated a lot longer. And it's good news, because in this case, wheels need less maintenance, which saves the airlines money. Now, the pressure in airplane tires is 6 times bigger than the pressure in your car's tires. It's 200 psi, which stands for 200 pounds per square inch. And that's what you'd feel if you took a dive 450 feet underwater. Or rather, you wouldn't feel because the maximum pressure a person can withstand is only about 50 psi. But if we speak about airplane tires, such high pressure makes them strong. It's next to impossible to overflate a tire to the point that it explodes. Now, it's true that overflating can reduce traction and put more pressure on airplane wheels. But if a popped tire situation happens, it's mostly because of the thing being underinflated. Even if it did happen on your flight, chances are you wouldn't even notice. Remember, there can be plenty of wheels on large airplanes, like an Airbus A380 or Boeing 747. And if one of the tires fails, the plane will still land safely. Now, there's one more thing why aircraft tires must be strong and durable. When a plane touches the ground, its tires aren't rolling at first, they're just skidding. So, in other words, the plane is dragging them along the runway until it slows down enough for the wheels to be able to rotate. This is when you can see the tires smoking after the touchdown. At this moment, they're accelerating to catch up with the landing speed. This whole landing situation also led to tires having grooves cut in them. If they had block patterns, like the ones car tires have, these blocks would simply fall off as soon as the plane wheels touch the ground. The most serious tire wear happens exactly when the rubber comes into contact with the runway. Oh, by the way, have you noticed how tiny and skinny compared to the huge fuselage airplane tires are? Don't worry, they're just the size they need to be. Larger tires would be pointless, since they wouldn't make landing more effective or safer, but they would add extra weight. And you probably know that the heavier a plane is, the more fuel it uses and the more money an airline loses. So engineers try hard to make wheels as small and, at the same time, as safe as they can be. After plane tires are produced, they always get tested. Manufacturers create computer simulations that check how tires will behave if they're pushed past their speed limit or get overloaded. They must be able to withstand pressure that's 4 times stronger than their usual one and should cope with this situation for at least 3 seconds. As for the strongest tires, they shouldn't blow out even at a landing speed of 288 miles per hour. The same computer programs figure out how tires will react to standard landings, takeoffs, and even taxiing, and then prototypes are created. And still, airplane tires aren't entirely safe from bursting. Accidents did happen in the past, and planes did skid off runways because of one of the tires exploding mid-landing. There were also cases of tires bursting mid-air. If it's just an exploded tire, there's nothing too bad. But tire fragments can get into the engine or cause serious damage to the fuselage. That's when the incident immediately becomes more dangerous. Besides, when a plane lands with one or several damaged tires, the load gets uneven and it puts stress on the landing gear. In the worst-case scenario, all tires, even good ones, might need replacing after such an incident. You can't argue that airplane wheels are cool, but sometimes they need additional help. I'm talking about hydroplaning, a situation that occurs when the runway is covered with a layer of water, preventing a landing plane from braking or stopping in time. The aircraft just keeps skidding forward, unable to find traction. The same can happen to your car on a rainy day, by the way. That's why some airports have grooves on the runway. Water flows into these grooves, making the surface not so slippery and dropping the chances of hydroplaning. Pilots claim that the difference between grooved and non-grooved runways is dramatic, and all that sounds pretty groovy to me. Hey, if you learned something new today, then give the video a like and share it with a friend. And here are some other videos I think you'll enjoy. Just click to the left or right, and remember, stay on the bright side of